Is it possible to get something from nothing? This is the story of a very important number, but a number that wasn't always a number. In fact, it was much less than a number until relatively recently. This is the story of zero, and it's a story that takes a tortuous and meandering route through 1,500 years of human history. Today, we enjoy zero in all its glory, where it takes on two roles. The first is as a placeholder within our positional number system. Zero notes an absence of a value and allows us to create huge numbers without the need to create new digits. So we know 30 is larger than 3 and 300 is larger than 30 and 3. The second use of zero is as a number in its own right, the middleman, if you like, between positive and -1, and enjoying nearly all the same benefits as other numbers. We can subtract, add, multiply by zero, but dividing by zero just doesn't work. For example, you can't divide one chicken by no chickens. You might suggest the answer is infinity, but it's not, because infinity isn't really a number, it's a concept. Mathematics developed from a very practical desire to count things, such as the passage of days or the quantities of chickens you owned. To manage this, ancient civilizations developed rudimentary number systems. For example, the Babylonians used two symbols in different arrangements to create unique numbers 1 to 60. The ancient Greeks and the Mayans also developed their own number systems, and all of these civilizations are thought to have created their own rough concepts of zero as a placeholder. But it wasn't until the Indians began developing their own number system that zero would be defined explicitly. Their early number system would also evolve into the one that we use today, initially with 9 number symbols and then a small dot used to mark the absence of a number. In the 7th century, mathematician Brahmagupta developed terms for zero in addition, subtraction, and division, although he struggled a bit with the latter, as would academics for hundreds of years to come. As the mathematics of India matured, it found its way eastwards to China and westwards, influencing the Islamic and Arabic cultures where it was instrumental in trade. But zero found resistance in Europe, as the Hindu-Arabic system was opposed by the Roman Empire's established numeral system. However, by the 13th century, academics such as Italian mathematician Fibonacci were championing the new number system in their work, helping zero to gain a solid foothold across Europe. Over the next 400 years, as mathematics evolved from practical applications to ever more abstracted functions, zero would form the cornerstone of calculus. Calculus allowed anyone to break dynamic systems down into smaller and smaller units approaching zero, but cunningly avoided the trap of having to divide by zero. Zero had now become a celebrated tool in the mathematical arsenal, and as the binary numerical system formed the foundation for modern computer programming, zero once again stepped into the limelight to prove its worth. And so it seems, after all this time, it was finally possible to get something from nothing.